Hi everyone, welcome to MathsPar. This video is about tangent properties of circles. What do you mean by a tangent? For a circle, a line drawn from an external point, if we assume this as external point, and if a line is drawn to the circle in such a way that it touches the circle at exactly one point, then that line is known as tangent. Then now we are going to learn the properties of this tangent. So the first property of tangent says that the tangent at any point of a circle and the radius through the point are perpendicular to each other. How do we prove this? Let us see. Let us draw a circle. Let us assume that a tangent AB is drawn to a circle and assume that OP is the radius of this circle. Then if I mark some point Q here and join this till the center of the circle, then I find that there is some point R which says that OR is the radius of the circle and OP is also the radius of the circle here. So by this we can say that OR is less than OQ, but OR is OP. Why OR is OP? Because both are radius of circle. So OP is also less than OQ. Now let us see if I take some point X here, then also OP is less than OX. If I take another point Y here, then also OP is less than OY. So for any point taken from P to B on the tangent will be always, so any point taken from P to B on the tangent, the OP measure will be less than that measure through the center of circle. If I consider this as Z, then OP is less than OZ. Similarly, if you come to the left side, that is from P to A on the tangent, there also if I take this point as some D, then OP is less than OD. Then if I take E, then OP is less than OE. So now we observe that OP is the only shortest measure. OP is the only shortest measure. Then we conclude saying that OP is perpendicular to AB. So the radius, this is the radius, will be always perpendicular to the tangent drawn to a circle at a point. This concludes saying that the tangent at any point of a circle and the radius through the point are perpendicular to each other. This is the first theorem. Let us look at the second theorem. If two circles touch each other, then the point of contact lies on the straight line drawn through their centers. There are two ways that the circles touch each other. First, two circles touch each other externally, and the other two circles touching each other internally. Now, the point of contact is this and lies on the straight line drawn through their centers. So, there is one common tangent drawn when two circles touch externally, and here the point of contact lies on the straight line drawn through their centers, and the point of contact is the same. So, when two circles touch each other internally or externally, the point of contact lies on the straight line drawn through their centers, and one and only one tangent passes through the point of contact. Now, let us look at the third theorem. Before we look at the third theorem, let us know how many tangents can be drawn to a circle from an external point. If this is a circle and its external point is this, then how many tangents can we draw? We can draw only two tangents from an external point. We can draw only two tangents from an external point. Then, being knowing this, if two tangents are drawn to a circle, then three things will happen. What are those three things? Both the tangents will be equal and the angles which are formed at the center with respect to the length of the line segment from the center of the circle to the external point are equal, and the angles at which the tangents are inclined onto the circle will also be equal. How do we prove this? Let us have a look at the proof. If two tangents are drawn to a circle from an external point P, that is PA and PB, then by the first theorem, tangent at any point of a circle and the radius through the point are perpendicular to each other. So we mark 90 degrees and 90 degrees here, then we join OP. Now here if we look at these two triangles, then these two triangles are right angled triangles in which OA is the radius, OB is also radius. So we know that angle OAP is equal to 90 degrees and angle OBP is also equal to 90 degrees. Then OA is equal to OB because both are radius of circle. Then we also have whatever side is opposite to the right angle is called as hypotenuse, and we have the common hypotenuse for both. So here we write OP is equal to OP, common hypotenuse. So by right angle hypotenuse side congruency, these two triangles are congruent to each other. That is, triangle OAP is congruent to triangle OBP. When two triangles are congruent, their corresponding parts are equal. So by CPCTE, that is, corresponding parts of congruent triangles are equal, we write AP is equal to BP, that is, two tangents are equal. Then angle APO is equal to angle BPO. That is, angles at which the tangents are inclined onto the circle are equal. Angle AOP is equal to angle BOP. This says that angles subtended by the tangents at the center of circle are equal. So by this we conclude saying that if two tangents are drawn to a circle from an external point, the tangents are equal in length and they subtend equal angles at the center of circle, and the tangents are equally inclined to the line segment joining the external point and the center of the circle. Thank you.